Hi, welcome to BC Video 9.18 Part 2. More on sequences, recursive sequences, limits of sequences, graphs of sequences by hand and with the TI, and convergent versus divergent sequences. Okay, a recursive sequence is where they have to give you the first term. Sometimes they might have to give you the first two terms, and then they give you a formula which describes each term in terms of the previous terms. Usually it's the previous term. Sometimes it could be the previous two terms. So, for example, now they have to give you the first term, at least. In this case, they're telling you the first term is 6. And they're giving you the formula, the recursive formula, which is that the k plus first term is equal to 1/3 times the kth term squared. So, therefore, our A2, if you let k plus 1 be 2, then that means k is 1. So A2 would be, according to the formula, 1/3 times A1 squared, which is 1/3 times 6 squared, etc., which is 12. Now, when it's time to find A3, you're going to need A2 because each term is defined in terms of the term before it. Sorry, there's so many word terms in there. So the third term is 1/3 the second term squared. Of course, we had to find the second term in order to do this. And then we get 48. And that process keeps going on. The fourth term will be 1/3 times the third term squared, and etc., etc., etc. Okay? So the sequence is actually 6, 12, 48, and then whatever 16 times 48 is. I really don't care. It's too big. Okay, now we're going to be graphing a sequence since they defined it as a function, but the thing you got to keep in mind is that the domain is integers. So we're going to have these dot functions, the graphs. You're not going to connect the dots. So if you have, for example, the sequence an is 2n minus n plus 1, you can think of it as graphing the function f of x equals 2x plus 1, but it is an extremely restricted domain. X can only be 1, 2, 3, etc. So as you can see, we're just going to get these dots is all we're going to get. Now they fall on the line 2x, y equals 2x plus 1. Limit of a sequence, we've already talked about that. That means the limit as n goes to infinity of the formula for the sequence. In our case, if we took the sequence that we just looked at, 2n plus 1, again, you could replace n by infinity. 2 times infinity is infinity, plus 1 is infinity, and hence we say that this sequence diverges. So, again, finding the limit of a sequence means finding the limit as n goes to infinity an. In effect, that's really what we used to call the horizontal asymptote. So if you get an actual number, then it exists, then we say that the sequence converges to that number. If, on the other hand, you get infinity, then we say that it diverges. Now, if you get infinity, it diverges. If you get negative infinity, it diverges. But there's also this weird situation where the limit as n goes to infinity doesn't exist. Now, here's an example. Limit as n goes to infinity of sine x, that just keeps bouncing up and down, does not approach a particular number. It doesn't go to infinity or negative infinity, but nor does it equal a particular number. So we say the sequence diverges. Okay, so they're going to ask you to graph some sequences, and numbers 15 through 18 is one of those matchy things. So they give you 4 graphs and 4 different sequence formulas, and you got to match them up. So again, always remember that the domain of any sequence is 1, 2, 3, etc. Hold on. Hi, sorry about that. Okay, so remember we look at it as a function. So in our case, if we replace those n's by x's, it's like graphing the function y equals x over 2x plus 1. So if you were to actually plot those points, again, you're plugging in x equals 1, and you'll get the answer of 1/3. And then you'll plug in x equals 2, you'll get 2/5, etc., etc. And then all you get is those disconnected dots. You cannot connect them. And of course, there's nothing in the second or third quadrants because that's where x would be negative, and our domain is all positive integers. Okay, so the last thing is graphing these on the calculator, and they're going to ask you in numbers 41 through 44 to use a calculator to graph the first 10 terms of the sequence on the calculator. Okay, so what you're going to do is on the calculator, you're going to go to the graph mode called sequence. So I'm going to do that with you. I'm in the graph mode right now. I don't know if I can make this bigger for you to see it. Yeah. Oh my. Oh, now the equation's really tiny. Okay, whatever. So, you know what? That's ridiculous because the graph is just not exciting enough. I think it's better that you be able to see the actual function. Okay, so when you go to menu and you go to 3 like you normally would to go for parametric or polar, you're going to see that one of those options, oops, sorry, is option 6, which is sequence. And we're going to do sequence. Okay, now, so as you can see, let me go back here. Okay. So we're going to take an example. I'm going to take, this is like number 41, 2 minus 4 over n. So the first thing you'll notice about the screen is it's not f of x, it's u1 of n. Okay, so you have to express it in terms of n. The reason it gives you initial terms is because if you have a recursive sequence, you'd have to tell it what the first term is. And by the way, you can only have one term. You can't do two different terms. Okay, notice how it starts at 1, which our domain is 1, 2, 3, etc., and it's going to go up by 1. So it's actually going to plug in n equals 1, n equals 2, etc., etc., etc. Okay, so the example we were looking at was 2 minus 4 over n. So I'll show you that, 2 minus, and then I'll do the fraction 4 over n. What the heck, I'll just do 4 divided by n. Okay. All right, so when I press enter, you can see the graph that you're going to get. Okay, notice they're nice big dots. All right, so as far as the window, you could limit your window. Notice how I limited my window, an x min of 1 and an x max of 10 because, you know, considering our domain is 1, 2, 3, etc. It's interesting how it tells you to give it as a function of n, and yet it still labels the axes as x and y for some bizarre reason. But notice here it shows you the function in terms of n.